Okay, everybody. So what we're going to be doing today is the definition of the derivative. And so good news and bad news. So good news, there's actually two pieces of good news. I'll even write them. Good news. Number one, after we're done with this, you won't really have to do it again for a while. Or actually, you won't have to do it again. So we don't spend very long using the definition of the derivative. So we don't use the definition for very long. Why not? Because we're going to learn some shortcuts, and then once you learn the shortcuts for derivatives, you use the derivatives you use those shortcuts 100% of the time. Okay, so we don't use the definition of the derivative for very long at all. The other good news is that no, there is no other good news. I lied. The bad news is that these problems are a little tricky. This can be a little tricky, but that's fine because really there's only 3 different types of problems that you need to be able to do, and then you'll be good to go. Okay, so there are 3 basic types. 3 basic types you'll need to know. And you've seen them before, actually. So you're going to see polynomial type. You're going to see root type, like square root. And you're going to see fraction type. And so you might remember those from back when we did limits. And really, that's all we're doing again is the same type of thing. Okay, so with that said, let's get our definition of the derivative so we can get going. So we did the slope of the tangent line before in the previous lecture, right? So you have a function like so. That function is y equals f of x. And we know that at one point here, if I put an a here, there's a point on the curve. And then if you take another point on here, and you could call it a plus h, you get another point on the curve. And we were guessing at what the slope would be if we took this point over here and we just slid it towards the other point. Then what we'll have is a secant line like this will become, as h goes to 0, will become, let's see here if I can do this. I have to draw kind of the same graph. It doesn't really need to be perfect. It'll turn into the slope of a tangent line, right? So this is a secant line between 2 points on the curve, and this is a tangent line just at a single point on the curve. I have a very squeaky chair, sorry about that. Okay, so that's what we got going on here. And that's great. What's the definition of the derivative? So here's the definition of the derivative. Definition. And really, it is just the definition of the tangent line slope. Okay, so the derivative of f of x evaluated at x equals a is denoted f prime of a. Can I turn that into an a? Yeah. F prime of a, and you calculate it this way, and is computed this way. So f prime of a is the limit as h goes to 0 of f of a plus h minus f of a over h. Okay, so that's the definition of the derivative that we're going to use. And what it is, the main interpretation, I mean, there's many interpretations, but the interpretation is what? Number one, f prime of a is the slope of the tangent line to y equals f of x, I want to say, so I'll erase that, to y equals f of x at the point a comma f of a. That's one thing it is. Another thing is it is the instantaneous rate of change. Actually, I'm going to use that third one. I'm going to do another thing related to the tangent line. You could also say that f prime of a is the slope of the curve y equals f of x at, again, a comma f of a. So those get used interchangeably. So you have slope of the tangent line and slope of the curve, right? Because at this point right here, the tangent line and the curve, right, the pink line and the blue line both have the same slope right there at A. Okay, and so that's why it's the slope of the tangent line, but it's also the slope of the curve. Okay, and what else can we say? Now we can say f prime of A is the instantaneous rate of change of f of x at x equals a. What else can we say? If f is measuring distance or position, if f of x measures a distance or a position, then f prime of a is the instantaneous velocity, which you've seen before, instantaneous velocity of, whatever object we're measuring position or distance of. So instantaneous velocity of whatever object f measures distance or position of. Okay, so those are several interpretations there. And, which ones are we going to use in this section? I don't know. Let's find out. But if we don't use them in this section, you still need to know them later on anyway, so it's not wasted time. All right, so this is our basic formula that we're going to be using. And we already had it from before. It's the slope of the tangent line, only we didn't take it formally with a limit in the previous section. We just kind of guessed at it. In this section, we're going to calculate it formally, but we know how to do limits, so we should be fine. So let us just try one. And I'm going to do a polynomial first. So let's find the derivative of a polynomial. Given y equals, let's say, I'm going to go 3x squared. Find f prime of 2. All right. So when we're starting, this is how they'll be given to you. They give you a function, and maybe I'll call it f of x, like that. And they want the derivative at a point, which is what this is. Okay, so the way you start is by writing your definition of the derivative. We have f prime of x equals limit as h goes to 0, right? So we're just looking up here at our formula. I'm just going to copy this formula down. The only thing I'm going to do is you've got this a here, and I'm going to replace it with what that number is for my problem. So I've got 2. So I have f of 2 plus h minus f of 2 over h. Okay. Now before I get too into this problem, I want to label what type this is. So this function right here, this is a polynomial. So this is the polynomial type. So this is an example of the polynomial type, and you'll have to do it. So let's see here. So there we go. Now, once you write down what the definition says, then you need to evaluate this limit for this particular function, right? So you've got the limit as h goes to 0 of f of 2 plus h. Well, f of 2 plus h means plugging the 2 plus h in for the x. So you have 3 2 plus h squared. That's f of 2 plus h. And then minus, then you have f of 2. Oops. You have f of 2, which is plugging a 2 in for the x. So 3 2 squared. Like that. Okay? Now, once you have it here, what you want to do is you want to just multiply out the numerator. So just multiply it all out and see what you get. Now be careful to, handle any pluses and minuses correctly here. So how are we going to do this? Well, you have to multiply out 2 plus h squared, right? So make sure you can multiply things like 2 plus h, 2 plus h. You'd get 4 plus 2h plus 2h plus h squared. So what you get is 4 plus 4h plus h squared minus, and then you got 3 times 2 squared. 2 squared is 4, 3 times 4 is 12. So we're here. Keep working out that numerator. We're not done yet. So multiply that 3 in through there, and you get 12, 12h, 3h squared minus 12 over h. Looks like our 12s cancel. I'm going to copy that down again. Now, what will happen in every one of these is that at some point you're going to have an h on every term, right? You've got an h there, you have an h there, you've got an h there. H is on everything. So when you get it to that point, what you need to do is factor out an h in the numerator. Okay, so we need to factor out that h in the numerator. When we do that, we will get whatever we get. So take out the h, and you're going to have 12 plus 3h over h. Now, why do you think we factored it out? Well, we factored it out so there would be an h on top and h on the bottom that was factored out. So we want to cancel that h now. Like that. Now, once we've done that, we've got 12 plus 3h here, right? No denominator, so there's no divide by 0 anymore, which was the problem at the beginning, although I didn't make a big deal out of that. So we get here, and then what are we going to do? Well, you can just plug in your h equals 0 now. So 12 plus 3 times 0. So what is that? It is 12. So what did we just do? Well, mostly what we did was we did the derivative here. Also, wait, come back here to the very top. I was supposed to be evaluating f prime of 2, and I did, but I didn't call it that for some reason. Hold on. This should have been 2, right? We were calculating f prime of 2 the entire time. So back down here, what we have is, so f prime of 2 is 12. That is what we just did. Okay, and that's how you do the polynomial type. You just basically write out the definition and multiply out the numerator and start canceling stuff. Right? Now let's do a different type. Let's do maybe a root type. Okay, so what are we going to do? I'm going to say given, let's give it a different name just because. Let's call it p of x equals, what will it be? How about square root 5x plus 2? Okay, and what do we want? Find, let me think. P prime of, what do I want to put in here? Hold on. 1, no, 2, no, 3, 4, 5, 6, 7, 8, 9. Wait, 9. 9's good. No, it's not. I lied. 10? It doesn't matter. Okay, so I was trying to see if there was a good number there. There is not, so I'm just going to pick a number. We're going to find p prime of 3. It's just a number. Okay, so how are we going to do this? Again, you're going to start with that definition. So the definition for p prime of 3 is p prime of 3. Should I be using a darker color? Hold on. P prime of 3 is the limit as h goes to 0 of p of 3 plus h minus p of 3 over h. Right? So we're just writing out the definition of the derivative. Then we need to plug these numbers into this function for x, which, you know, it's going to be a little awkward, not too bad. I'll give myself room. We plug a 3 plus h in there. So we have a square root 5 parentheses 3 plus h plus 2 minus square root 5 3 plus 2 all over h. Now these square roots aren't going to work out to like really nice numbers or anything, unfortunately. I'll give myself even more room here. But it is what it is. So all we can really do is you can just work out what's in the square root there a little bit. So if you multiply out the stuff under the first radical, you get 15 plus 5h plus 2. And if you work out the second one, you get 15 plus 2, which is 17. Like that. So let me do the small amount of simplifying that there is. All right, so that's where we are. So I just added the 15 and the 17 there. Now you have to remember what to do here, and you have to think back to when we did limits, and the key for doing this was when you had this kind of thing going on, you were going to multiply by the conjugate, right? So these are not new issues. They're old issues, but we're gonna have to remember what we did before. So when we multiply by the conjugate, remember the conjugate is the same term that you have, like the conjugate of a minus b is a plus b, and the conjugate of a plus b is a minus b. So we're just going to write out this same thing The only thing that we're changing is that minus sign in the middle, we're changing to a plus. Okay, so that's what you get when we multiply by the conjugate on the top and the bottom. Remember what the point of this was? Remember that if you multiply a minus b together with a plus b, conjugates, the result is a squared minus b squared. Okay, so what you get when you multiply this, and I'm not going to take more space to do it than necessary, is if this is your a and this is your b, then when you get your a squared and b squared, you're just going to have the first square root squared minus, in this case, there's another square root, which will be squared. And then in the denominator, maybe you remember what to do down here. And the thing to do in the denominator here is nothing. Just write out what you get and then stop. All right, so we're here. Now in the numerator, we've got a couple of squares. Well, if you square a square root, it's going to cancel out. So when you square a square root, they're going to cancel. You're going to be left with 17 plus 5h minus, and same thing on this other one, the 2 and the square root cancel, and you have 17. In the denominator, what do? Nothing. You just keep writing it. Okay, so we're here. Well, now what? Well, something you should be able to see is that we've got a 17 minus a 17. So those can cancel. So we'll do that. So now we have the limit as h goes to 0 of what? 5h on top. And 17 plus 5h plus square root 17 down below. What do you think we do now? We're going to do canceling the h. Right? Canceling the h is always what your goal is on these, because we have h goes to 0, which means we can't have h in the denominator. You can have this h in the denominator. That one's fine because that's not going to give you a divide by 0. But the one out here, the one at the beginning, that one's an issue. All right, so we cancel an h. While we're at it, I'll say we canceled those 17s. Okay, so we canceled the h. Now what do we have? H goes to 0, 5 over square root 17 plus 5h plus square root 17. Now canceling that h top and bottom means that there's no divide by 0 anymore. And if there's no divide by 0 anymore, we have learned in limits like this from the past that we can just plug in h equals 0 now to evaluate it. So just plug in h equals 0 and we should get some kind of an answer here. 5 over square root 17 plus 5 times 0 plus square root 17, which is, well, when you work this out, you have 17 plus 5 times 0, but 5 times 0 is 0. So you just have square root 17 plus square root 17 down there in the denominator, which is, well, when you add square root 17 plus square root 17, you get 2 square roots of 17. And that's your answer. Okay. And that's the root type. Okay, so if you look at the book's solution for this, they're going to do it exactly the same as what I did here. It'll be like the same type of thing every time here. All right, let us try a fraction type. That's the last type. What I want to see now is, do I want to do the hardest possible fraction type, or do I want to do kind of an easier one and then a harder one? Let us see. This homework is kind of hard. All right, we'll do kind of a hard one because they do kind of a hard ones. Okay, so what are we going to do? Again, another one. This is going to be fraction type. Fraction type. All right, what type of fraction? Well, I'm going to give you this. So find t prime of 10 given, try again, given t of x equals x plus 2 over negative 2x minus 2. Those minus signs are a little bit annoying, but we'll do it. This is straight off the homework. So let's try it. Okay, so how are we going to start? Same way we started the others, right? You're going to go t prime of 10 and say, well, what's the definition say? Definition says should be t of 10 plus h minus t of 10 all over h. Okay, so what we're going to have to do is we're going to have to plug the 10 plus h. I don't like the way that highlights. You'll have to plug the 10 plus h into that x, and also you're going to plug the 10 into both of those x's. So this is the hardest one to write, especially since I wrote the formula wrong here. Hold on. I lost a limit as h goes to 0. Okay, now we have it. Limit h to 0. Give ourselves some room. Try to write this out. All right, so you are... Okay, that's out of the way now. You need to plug in the 10 plus h in for both of those x's. So when we do that, that's going to be 10 plus h, like think of it in parentheses, plus 2 on top. On bottom, you have negative 2, 10 plus h minus 2. So that's how you plug in the 10 plus h. Then you have minus, and we're just going to plug in the 10. So 10 plus 2 over negative 2, 10 minus 2. And then in the denominator, again, we still have an h. So let us do a little bit of simplifying. Right? These have the most simplifying that you have to do here. So here's what I'm going to do. I'm going to multiply out everything I can everywhere I can. So we're just simplifying. All right. So in the numerator here, I've got 10 plus h plus 2. Well, 10 plus h plus 2 is just 12 plus h. So just write that. Now in the denominator, you're going to have to, multiply all this out. When I do that, let me just try to save some time here. So the negative 2 times the h is negative 2h. Then you have the negative 2 times 10, which is negative 20, and then there's a negative 2. So negative 20 minus 2 is negative 22. Okay. And then we have a minus. And then on the other fraction, we've got 10 plus 2, which is 12. And then on the bottom, negative 20 minus 2, which is negative 22 over h. Okay, so there we go. Now, what are we going to do? What we need to do now, I'm going to erase that real quick and just write a little. Okay, so here's what we need to do now. We need to get a common denominator so we can add these fractions together. Okay, so I'm going to give myself plenty of room, hopefully. I need to rewrite it, so I've got 12 plus h over negative 2h minus 22, space, minus 12 over negative 22. Now, if you want, you can reduce that. So I'll just reduce that fraction there. Actually, we'll do a couple things. So I've got a minus here, and I got a minus here, right? So minus a minus is actually a plus. So let's turn that into a plus. And then 12 over 22 is, if you cancel a 2 out, will give you a 6 over 11, right? And then over h. Now, what we need to do is get a common denominator now. So common denominator, because we need to add those fractions is what we need to do. So basically your common denominator is just going to be this 11 times this negative 2 minus 22, right? So that means you're going to take this side and say it's missing the negative 2h minus 22. But you have to multiply by that on top and bottom. So when you multiply out that denominator, you're going to have the 11 and the 2h minus 22. Now the first fraction, what's it missing from the common denominator? It's just missing the 11. So you just need to multiply by 11 over 11. So that's how we're going to get our common denominator. Let's write that out, and then we'll add them. Actually, let's well, no, okay, fine. We'll do this slow. Negative 2h minus 22, 11, and then on top you have 12 plus h times 11, and then plus fraction here, 11 times negative 2h minus 22, and on top 6 negative 2h minus 22. All right. Now then we can add those fractions. Now that we have a common denominator. So we add these fractions. So we're just going to have one fraction over negative 2h minus 22 times 11. And in the numerator, which I did not give myself enough room to write, we're going to have both of these things, right, added together. While we're at it, we should distribute that 11 on the first one and the 6 on the second one. So on this one right here, multiply that 11 through. So you get 11 times 12, which is, what is it? 11 times 12 is 131, is that right? I think so. And then 11 times h is 11h. And then plus, we have the 6 and the negative 2h is going to give me negative 12h. And then the 6 and the 22, oh, what's 6 times 22? 6 times 2, 20. 6 times 20 is 120. And then plus 12, so 132. Looks like negative 132. What else? Oh, I added these wrong. This 132, right? I think. Wait, is it? Yeah, it's 132, right? 11 times 12? Hope so. Okay. Anyway, so we added those fractions. What can we do to simplify? Well, one thing we can do right away is that 132 will cancel out that 132. So let me just rewrite it. So we've got, what do we have? We have 11h. Oh, and we should add those. Hold on. After you cancel those, you have an 11h and a minus 12h. Well, 11h minus 12h is just negative h, negative 1h. So you have negative h over negative 2h minus 22 times 11 over h. Okay, now what you can do here is you can simplify this fraction. So it's a complicated looking fraction, but there's basically two things that are going to happen on these. Either you're going to get an a over b over c, that's the kind of fraction we have here, in which case your result is a over bc, or you're going to get an a over b over c over d type of thing, in which case your answer is a over b times d over c. So whichever one applies is what you do. Looks like we're in this case up here. So we can rewrite this fraction as basically this part right here is the b over here, and the h is the c. So when we write it out, we're going to have negative h over negative 2h minus 22 times 11, and then there's a h. Okay, like that. Now once you have it there as one fraction, we should be able to cancel the h again. All of these, you're eventually going to be canceling an h in the numerator and the denominator. So this is where it happens here. So what do we have? We have the limit as h goes to 0 of negative 1, right? We canceled the h, but it's still, we left the negative up there. We have negative 2h minus 22, and we have an 11. Well, once we cancel the h, we can just substitute in h equals 0 now. So sub in h equals 0, and that's how we're going to evaluate the limit. So you put in h equals 0, we get negative 2 times 0 minus 22 times 11. So that is, doesn't even look like an 11. Let me fix it. So the 2 times 0 is 0. So you have just negative 22 times 11 there. So we have negative 1 over negative 22 times 11. So what's 22 times 11? Do that in my head. 242. Is it negative 242? I feel like. And if that's the case, then I should have, what were we calculating? T prime of 10. So I think T prime of 10 should be 1 over 242. And what I did there was I canceled the negatives, top on the bottom. Yep, that is correct. So, I mean, you can see that that fraction type is the most tedious that you have to do. It's all the stuff with common denominators. Yeah, so if you think about it, technically, the algebra is not hard on this, right? Because it's just adding fractions and simplifying fractions. But it is, right? It takes a lot of lines of work, and every line of work is really an opportunity for you to make a mistake. And so the longer the problem, just the more mistake prone it is. Keep in mind that you can check your answers on Wolfram Alpha very easily. So like this one right here, let me write it down because I'm going to move away from this page. So the function, write down the function here, was x plus 2 over negative 2x minus 2, and we wanted it at 10. All right, so here's what I mean by that. If I go to Wolfram Alpha or Symbolab, but Symbolab doesn't work very well on my iPad, so Wolfram Alpha, I can say t of x equals, and not that, I don't know what that is. Our fraction, or our problem, was x plus 2 on the top over parentheses, negative 2x minus 2, and then you just ask what you want. Find t prime of 10. And it should understand this, and if not, we'll just write it a different way. So it looks like it did not understand it because it wanted to interpret the t prime of 10 as part of the thing there. So if I say like derivative at 10, might do it that way. We'll make it do it. Nope. All right, third time's the charm, right? Try this. Let's go back here. Write it at the beginning. T prime of 10 if. Okay. I feel lucky. It really can do the derivative. Derivative at t equals 10. Oh, wait, it's x equals 10. Derivative at x equals 10. Okay, if this doesn't work, we're going to Symbolab. Oh, finally. Derivative at x equals 10. It did it. Okay, 2 over 42. 242. But Wolfram Alpha does not show you work unless you pay them money. Right? Unlock step by step. I don't even know what that costs. Let's look. I want to see. Go Pro. $475 per month. Billed annually. Oh, that's sad. Okay, I don't like that. So let's go Symbolab. Even though Symbolab's really hard to type stuff in for me. Enter a problem. So they got symbols for all this stuff here. They don't have a good one for derivative at a point though. So I don't know, but yeah, you know what? I don't think I'm going to do this because I think it'll be better in the next lecture when we're doing a slightly different type of derivative. So you can check your answers on Wolfram Alpha. I mean, try to remember what worked, right? Not everything worked. All right, I have to close the app there and then open it up. Okay. So remember how to type it into Wolfram if you use Wolfram to check your answers. So your Wolfram would have been able to do every one of these problems, okay? You just have to type it in so that it understands. All right, so let's pick a new one. Okay, I mean, there's a couple other types of questions in here that are just kind of, they're not really asking you to do anything. Like here's a problem given g of x equals e to the 2x, which is the definition of g prime of a. Now, they're not asking you to work it out. They're asking you to write the formula. So all you're supposed to do is you're supposed to write g prime of a equals limit as h goes to 0 g of a plus h minus g of a over h. That's the definition of the derivative, right? But they gave you a function, so they do want you to use that function. So you're supposed to say, well, that is actually, if you put in the a plus h in here for the x, it turns into e to the 2 a plus h minus, and then when you put in an a for the x, you get e to the 2a over h. And so all they want you to do is just to match this up with one of the formulas that they gave you. So yeah, and then this just matches up with one of them. So that if they don't give you an A, you're not going to be calculating it at this point. Okay, so you're just selecting the correct definition, basically. All right, so you have several of those. And yeah, so I mean, I think that's it actually. That's all the problem types on here. Okay, yeah, that's all the problem types on here. So we're going to be doing more derivatives in the next section. So I'm going to call this one done, and we'll be doing, honestly, the exact same thing in the next lecture. So let me hit stop.